Hello guys, welcome back to my channel. So today we'll be doing vector functions. We are going to consider limits of vector functions, integrating vector functions, and differentiating vector functions. So now let's start with a three-dimensional vector. So here we have our vector to be r, giving us f, g, and h. So now to take the limits of this vector function, we are going to take the limits of each of the components. Thus, we first take the limit of the I component, then the limits of the j component, and that of the k component. So here our resource is going to be a vector in this case. So now let's take our first example on taking limits of vector functions. So with our first example, we have to evaluate the limits of et minus 1 for t and t minus 1 divided by t squared minus 1. So here we are going to take the limit of the I component, that's et minus 1, and that of the j component, that's 4t, and that of the k component. We are going to have our limits to be, that's limits of et minus 1, then limits of 4t, then that's of limits of t minus 1 on t squared minus 1. So that's how we're going to take the limits. So now here let's consider that of the k component. So we have it to be t minus 1 divided by t squared minus 1. Now we can simplify this using difference of two squares. So we're going to have t plus 1, then t minus 1. So these two guys will cancel out. So we are going to have 1 on t plus 1. So we are going to write 1 on t plus 1 in place of what we have for that of the j component. So we are going to have limits of et minus 1 as t goes to 1, then limits of 4t as t goes to 1, then limits of 1 over t plus 1 as t goes to 1. So here for the I component, we are going to have e exponent 1 minus 1, and the j component will give us 4, and that of the k component is going to give us 1 over 2. So this is the limits of the given function, which can be rewritten as e1 minus 1i plus 4j plus 1/2 k. With our second example, we have to compute the limits of the given function below. So here let's take a look at the j component. So with the j component, when you substitute in t is equal to 1, we are going to have sine of 0 divided by 0, and sine of 0 is 0 divided by 0, and that's indeterminate, right? So we have to use the L'Hopital rule to compute this guy. So now differentiating the numerator gives 3 cosine of 3t minus 3. Thus we use the chain rule to differentiate this guy. Then that of the numerator gives 1. So now our limits will now be giving us, we have in the blue box. Now we now take the limits of each of the components. So we're going to have 1, then 3 cosine of 0, then e exponent 2, which will be simplified to I plus 3j plus e2k. So that's our limit. Our next subtopic is derivative of vector functions. Now, as we did in finding the limits of vector functions, in this case also we will just find the rate of change of each of the components. Thus we find the rate of change of the I component, the j component, and the k component. That's how we take the derivative of a vector function. So now let's move on to solve some examples. The first example on derivative of vector function, we are given the vector t6i plus sine of 2tj minus ln of t plus 1k, and we're being asked to find the rate of change of this given vector. Here we are going to differentiate this vector component wisely. So we are going to have r prime of t to be given as 6t5i, then plus, for that of the j, we are going to use the chain rule to differentiate. So we are going to have that's going to give us 6t exponent 5i plus, so with the j component we use the chain rule, so we are going to have 2 cosine of 2t j, then minus 1 over t plus 1k. So our second example, we have to differentiate the given vector below. So as we did for the first example, we are going to just differentiate this vector components wisely. So we first take the I component, we differentiate, then same for the j and the k components. So let's first simplify the I component. So the vector will now be simplified to t minus 1 on t plus 1, then t minus 1, t e minus t, then 4. So here we are going to have these two guys cancelling out, so that's going to give us 1 on t plus 1, and here will be t e minus t, then 4. So now with the I component, our u is 1 and our v is t plus 1. So we are going to have the rate of change of 1 on t plus 1 to be given as, now v is t plus 1. Now u prime will go to 0, minus, we keep u now, and v prime is going to give us 1. All divided by v squared, that's t plus 1 all squared. So we are going to have minus 1 on t plus 1 all squared. So that's the rate of change of the I component. That of the j component, we are going to use the product rule. So if we are to differentiate uv, then we are going to keep u, then we differentiate v, plus we keep v, then we differentiate u. Here we have to differentiate t e minus t. So we will now keep e minus t, then we differentiate t, that will give us 1. So we are going to have e minus t, plus we now keep t, we differentiate e minus t, that's going to give us minus e minus t. So we are going to have e minus t minus t e minus t, and we can simplify, this can be simplified to e minus t 1 minus t. Now that of the k component is a constant, so as we all know, the rate of change of a constant is 0. So our answer is going to be r prime is equal to so here the k component is a constant, so its rate of change will go to 0. So our answer will be giving us minus 1 t plus 1 squared e minus t 1 minus t, then 0. Story. Alright, so now our next subtopic is integral vector functions. So we have two types of integration, that's definite and indefinite integral. So if the integral is an indefinite integral, we are going to add a constant vector c, since we are dealing with vectors. Then we just have to integrate this guy's component wisely. Now for that of definite integral, just the same idea. You just integrate, then we substitute in the range of integration, then we evaluate our answer. So now let's try our first example on integrating vector functions. Let's integrate that of the I component. So for the I component, we are going to have our answer to be, that's we add 1, then we divide by the new exponent. For that of the j component, we are going to use integration by substitution. So we are going to let u to be equal to t squared plus 1, then we differentiate u to get 2t dt, then we now substitute in. So our answer is going to be minus ln of t squared plus 1. Then for that of the k component, we are going to have, for that of the k component, we are going to have 2t cube minus 2t squared, and then plus the constant vector c. So that's our integral in this case. With our second example on vector integration, we have to integrate this guy in the range of 0 to 1. So now let's compute this integral. So here we are going to integrate its components wisely as we've been doing. So you're going to have 0 to 1 cosine of t dt, then integral from 0 to 1 6t cube dt, then from 0 to 1 et dt. So we are going to have, when we integrate cosine, we are going to have sine of t from 0 to 1 out of the j component is going to give us 3 over 2 t4 from 0 to 1, and the integral of et is going to be et, so that will give us et from 0 to 1. So let's evaluate this guy. So you're going to have sine of 1 minus sine of 0, that's the upper limit minus the lower limit, and this will give us 3 over 2 1 minus 0, then e exponent 1 minus e exponent 0. Now let's now simplify this guy. So we're going to have sine of 1, now sine of 0 is 0, and this guy will give us 3 over 2, then e exponent 1 minus 1. So our answer is now giving us sine of 1i plus 3 over 2j plus e exponent 1 minus 1k. Thank you for watching. See you in the next video. Please make sure to subscribe. Bye.